Okay. This is the second video for tension, and I'm going to show you how to solve this. First of all, Eddie, thank you. There you go. Mo, what force is acting here?
Force of gravity.
Good. We have the force of gravity. Now, Manuel, is the force of gravity acting on both masses?
No.
Not kind of yes and kind of no, right? Max, what do I mean by that?
Because they're connected.
There's no friction, okay.
There's a normal force on that one because 30 grams. It's right.
Yeah, so Arsha, where is there a normal force? Is there a normal force here?
No.
No. Jeff, is there a normal force here? Yeah, there is. Ali, stop, please. Here there is gravity, but it's negated by normal force, right? So these two are equal and opposite, as Marco says, and we don't need to worry about them for this problem. But here, there is an FG that we do need to worry about, right? Now there's going to be a tension force up here. And that should be the same as the tension force here. Is there any friction acting backwards? No friction. So the net force on this block is going to be the same as the tension force forwards. Yes? Because the normal and the gravity are negated. Okay, so we know some things here, right? If you want to, if it works for you conceptually, there's a way you can kind of deal with these directions. It's kind of weird to think about, right? Because gravity's pulling down, but then this is moving sideways and that's moving in this weird. So if you want to, take your arms like this and just go whoop, that. If you straighten this out and just say, here's my 200 and here's my 300, there's really just one force, right? And it's going this way. You get that? So if I take this and I straighten it out like this, now it's just a tug of war. And this force of gravity is pulling the whole thing that way.
Well, just think of gravity actually first.
And there's no backward force here because we have no friction. Yes.
So are we thinking of like the force of gravity horizontal?
I'm so proud of you. You put your hand up. That's good. Sorry, say that one more time.
Horizontal? Like, do we think of it as horizontal?
Yeah, exactly. So the acceleration of a system like this, as Ali says, this is horizontal, would be exactly the same as the acceleration here. If there's no friction in it, it doesn't matter that gravity is pulling down. It's still going to pull this guy sideways. So you might as well think of it as a tug of war, and you're just pulling sideways. Now, are we pulling just 200? No. We got to pull 500 in total, right? Jeff, you had a question?
So the force of gravity would be your like total force, right?
That's exactly right.
And then
The force of gravity is the total force on the total mass. So let's calculate it first. How do we get this? Can we make G equal to 10? You guys okay?
Total mass.
Instead of 9.8, let's just say it's 10 meters per second squared. It makes things easier.
5,000.
So this is going to be 0.5 kilograms. Sorry, 0.2 kilograms. This equals mg, right? So this is going to be 0.2 kilograms times 10 is how much?
2.
So my force of gravity is 2 newtons. I know it's a little bit millions. 1.96, but we'll just call it 2. No, we're not going to do negative, but Nikki, that's a good question because this is down, right? But negative being down kind of starts to lose meaning when that force is pulling something sideways. See, pulleys mess everything up, right? Because then we have to say that this is also negative, and it's kind of weird, right? So I would just say, think of this as forward. There is no force backwards, so just leave it positive and we won't have to worry about those. So this force is 2 newtons. Now it's the force of gravity, but you can just think of this as an applied force that way. Okay? And we're looking for the Ft in here. Now Jeff was onto something there. So tell us again, Jeff.
After we get the 2 newtons, you can use the first one, the F net for the N net.
Good. So our F net is 2 newtons because there's no friction backwards, no other force, that's the only force. And as Jeff says, my F net equals MA. Danya, what can I solve for there?
Acceleration.
Good, good. We're gonna solve for A, right? How do we solve for that? Here. Good, perfect. So F net divided by M, that's gonna give us our acceleration, right? 2 divided by what?
0.5.
Good. So this is important. You can't just do the 200 mass because that 2 newtons is pulling all this junk. So we have to do 500 grams, which is 0.5 kilograms. And that should be 4, right?
So,
Max.
is the force of gravity the net force? Is that?
Yes. What? Tell me why.
Because there's no forces. Because you don't have other weights on it?
Yeah. Yeah. If I had friction here,
Yeah, that's
would
kinda
there
hard.
be would I be able to say that this was the net force if there was a friction force pushing back?
No.
No, then it would not be, right?
But what about
Yeah, carry on. I like this question.
the force of tension?
Marco, pause that for a second if you would.
That's, is that not slowing down how fast that 200 grams is moving?
Yes, but let me explain that. So that's a really good question. Let me draw this a little bit bigger. It's exactly the same.
And if you're saying force of gravity is net force, then the force of tension isn't included in that, right?
Right, and so how do I get away if this net force is sum of all forces, right?
Yeah.
So I can negate this gravity. Why? Because the table thing, the air track is holding this up, so these two cancel and they're gone, right? You can put them in the calculation, but they'll add to 0, so it doesn't matter. But what about the tension? How do I get away with saying this is the net force when there are tension forces here? Madison is going like this, and that's the key, is that the tension force pulling back on this 200 gram, what is it doing to the 500? Pulling it forward. Those two forces are always equal and opposite on one string or cable or rope.
Yeah, but there's a pulley in between, right?
Yes.
That's not change in it, and they're technically opposite directions.
What does the pulley change?
Direction.
Just direction. So in the real world, there are a little bit of forces here because this has friction. But if this is a completely frictionless pulley, there's no change in any of those forces. Even though you're bending it down, it's still moving the same as if it were just level. And so you can say that this and this are negated. They're the same at opposite directions. It's a bit weird, but it's true.
So the string would,
Yes, yes.
so when you say like tension force, is
Yeah.
it the force of the string acting on the two bodies this way? Is it the sum of those just without direction, or is it like?
It is the sum of these with direction. Because the direction is opposite, one's pulling forward and the other's pulling back, they add to 0.
Yeah, but then isn't the tension force just 0?
Yes. Together they're 0. but we want the magnitude, right?
Yeah, so what I'm saying is, like, actual tension force would be just the force that the string is acting on the two bodies added together without direction. So it's
That's
just
correct. Yeah,
magnitude.
yeah, that's correct. Yeah, so when I ask you to calculate this, sometimes kids will calculate it as a negative, and that's fine. It doesn't matter. It's either way, right? Now, let me finish this because class is over. If we get 4 meters per second, what you do is you look at these two guys separately. And you can say with this guy, the F net on the 0.3 kilos is just the tension force, right? So if you're in a rush and you get on a test and you look, you're like busy and it's the end of class and you're like, oh my gosh, I don't have time. I can't solve this. And then you go, wait, the mass on the end has only one force, and it is the tension force. So if I just solve for that acceleration and I go, this net force is also equal to MA, right? The net force on this block. So on the so that's going to be 0.3 kilograms, because it's in grams there. I times that by 4, and that's going to be 1.2.
You could also
Newtons.
double check it using the other way.
Yes. So if you have time, so that's the F net on the 300 grams or 0.3 kilograms. You can double check it on this mass, and you can say, okay, we have here 2 newtons pulling down. This is 2. If this tension force were 1.2, those added together are what?
0.8.
0.8. So the net force here should be 0.8, and if we do the mass times acceleration, we get 0.2 times 4 is 0.8. So because those two are the same, no, let me be really clear. Your quiz tomorrow is not on tension. It's on the F equals MA stuff, those 2 sheets that we did from before. And we have a long class tomorrow, so we can do that.